Okay, thank you, Dean. First, I want to start off with asking folks, how many of you have used something like a Google Cardboard or a Samsung Gear? Okay, good. There's a few of you that has, but some of you actually look like you haven't. The reason why I ask is because I actually was doing a presentation for some kids in the, I guess the high school age range over the summer. And it was surprising to me, and these kids, parents actually work in the tech industry. So it was very surprising to me to find that they weren't familiar with what Google Cardboard was or what Samsung Gear was or Oculus Rift, and that surprised me. So I guess it's a technology that's moving so fast that people aren't catching up as quickly as I was expecting. So what I want to do with today's talk is, let me use this. Here. First, I want to talk about what is AR and VR, and then talk very quickly about market forecasts, some general use cases, and then talk about some of the use cases that we could potentially try to get into a telco environment, and then summarize. Before we talk about specifically ARVR, how many of you are familiar with 360-degree video on YouTube? Some of you are. Okay. Okay, so it looks like some of you are, but for those of you who aren't, I just want to quickly show you a couple of videos that are on YouTube. This one we took, so we have a Bell Labs location in Naperville, and we just celebrated our 50th anniversary. Our location is actually 50 years old in Naperville. And we took our Ozo, so are people familiar with Ozo? Nokia has this 360-degree camera. It's a professional camera. So it costs $60,000, so you may not know. It's a professional camera. But you're able to take 360-degree video with the Ozo. And so we have one in Naperville, and we created a museum for our location. And then we created this 360-degree video and put it on YouTube. And on YouTube, you can see with our 360-degree camera, you can look all around our little museum. Right? So this one is a very simple video, and it's of one room, and there's nobody in here, and there's no sound, right? So, but it is possible to put in sound. So if you look around in YouTube and you look for 360-degree video, one of the things that you might find is Google's videos on the U.S. national parks. So this is one. Oops. And this has sound, and it has people, and it has movement. So you might not be able to hear, but he's talking. And while he's talking, you can actually move around to see where he's at with your mouse, because this was taking the 360-degree video. Okay. She's saying, look down. Okay. So I'm not going to show the whole video. But the point is, what some people have said is that this 360-degree video that you see on YouTube is like the gateway drug to AR/VR technology. Okay, so these videos you can actually put on something like a Google Cardboard or Samsung Gear, for those who are not familiar with it. It actually allows you to be fully immersed in this 360-degree video environment. And all you need to do is slip your iPhone or your Android phone, smartphone, into the device and play the video, and it'll appear as if you're right in that environment. Okay, so now let's talk about AR and VR. Some of you might have seen this Time magazine edition. They talked about virtual reality. Virtual reality is this fully immersive reality that puts you right into an environment that's either fully created from scratch or it's an environment that's been captured and recorded. So it's a real environment, but it's a recorded environment that you can still be a part of. And then augmented reality, if people are familiar, I assume everyone is familiar with Pokemon Go. So Pokemon Go is an example of augmented reality. So if you look through your device in something that's providing you augmented reality, you can actually see a 3D image that is in, as you're looking through the smartphone, you see the view of the environment that you're actually in, and then you can see the image, the 3D image that you're augmenting and adding into that environment. So the Pokemon characters, for example, can be now placed into your environment as if it actually exists there. And it's very popular, as many people are aware. And so there's virtual reality, there's augmented reality, and as Dean was alluding, there's also mixed reality that can combine VR and AR together in different use cases. Let's now talk a little bit about market forecasts and what's happening from a financial perspective in ARVR. So augmented reality is, so this particular, there's forecasts from multiple sources, right? And DigiCapital is one of them. They've done some forecasts out to 2020, and what they see is that augmented reality is going to reach about $90 billion by 2020, and virtual reality $30 billion. So about $120 billion in revenue by 2020 is the expectation from this particular source. What you may or may not be aware of is, while Pokemon Go is very popular, it's just one use case for augmented reality that's taken off, and not a lot of augmented reality use cases are available now. But virtual reality is actually much more popular today because you can get like a Google Cardboard for, $15, and then slip your smartphone in, and there's a lot of content that's already been created for it. Plus, you can use YouTube for a 360-degree video. So VR is actually what's taking off first. But the expectation is that in 2018, we're going to reach a tipping point where the use cases and content that's available will move more into the AR area as opposed to in the VR. So the expectation is, and these are expectations from various experts in the industry, including Apple, Tim Cook from Apple, who've said that they believe that there's a much bigger market for AR than VR, but VR is where we're going to start. And 360-degree video on YouTube is the very beginning of this. If we look a little bit more just into the VR market, in this particular forecast, you'll see that, and I'm not going to look at it, I'm not going to go over this in detail. I just want to show you that looking at the one from Piper Jaffray on the right-hand side, that their expectation is that by 2025, there's about a six-fold increase in revenue in the industry for VR. And as I said, AR is where people think the market is really going. So this is going to be picking up very quickly. If we look at investments, there's been a lot of investments in the last few quarters, and this is just looking back in 2015. It's not looking forward. You'll see that in 2014, there was a quarter where there was a big spike, and that big spike was the acquisition of Oculus Rift by Facebook. But as you can see, there's a clear upward trend in terms of investments for ARVR. So I just wanted to give some background there. For the VR market, there's a number of different general use cases that are possible and are already becoming available now in different forms. There's multi-user VR environments. So this is showing some of the different use cases and different use case categories, as well as what are some of the large players who are involved in those particular use cases. So there's multi-user VR environments, mostly in gaming. So you can imagine that there's a lot of games out there that can take advantage of this technology. Then there's live virtual attendance, and some of you may be familiar if you have a Google Cardboard or a Samsung Gear that there are sporting events that are actually streamed live 360 degrees that'll allow you to participate or attend an event without actually being there, but it'll seem like you're actually there because you're fully immersed in this environment using this technology. And then taking this another step, besides live events like sporting events, you could do virtual visits. So if you want to be able to go to places that you may, for whatever reasons, aren't able to travel to, but you're interested in seeing some of these sites and these tourist attractions, these locations are now building 360-degree video that users can now, just like the U.S. national parks that Google has provided on YouTube. Other locations are doing the same thing and creating these 360-degree videos so that you don't need to be there in person to actually be there and get the same or similar kind of experience of seeing places around the world, unique places around the world. So that's in the VR dimension. And in AR, collaboration is one area that could be very big for augmented reality. Because imagine either in the medical field or in engineering or in architecture or in art. There's many different vertical industries that could use AR for collaboration purposes. There's also transparent screens and other types of devices that are similar to these head-mounted displays like the Google Cardboard or Oculus Rift or HoloLens that give you the ability to see images, add images to your current environment as well. And then ultimately what we want to do is get to a point of being able to do holoportation, right? That's the ultimate that everybody dreams of. And after seeing the Star Wars movie, people have been dreaming about being able to do like something like a Leia message, or even more than that, being able to interact live with the hologram. So there are companies that are working on that. Microsoft, for instance, is working towards that with their HoloLens. So we hope to see that someday. Now, how does a telecom service provider leverage AR/VR communications? Obviously, they could do what a lot of OTTs may be doing, and that obviously is a possibility, is to take this technology and offer some solutions in a standalone fashion. But they're also deploying VoLTE today, and they're deploying video over LTE and RCS. And so we could leverage what they're putting in place from an IMS perspective. So, basic IMS today is getting put in place to replace the PSTN and PLMN and offer an interoperable IP communications solution. It's going to support voice using VoLTE and video over via LTE and messaging and sharing via RCS. And advanced IMS can leverage WebRTC, which if you had gone to the keynote, there's been talks about WebRTC here. So WebRTC doesn't need IMS, but you could integrate IMS with WebRTC, given that telecom service providers are deploying it. And another possibility is to integrate ARVR technologies with IMS. And so that's what I'm going to talk about in the next few slides, is how we may be able to do that in different use cases. But before we do that, I want to talk a little bit about some additional devices that are becoming available in this area, the 3D AR/VR space. So you need to be able, in order to provide these capabilities, you need capture devices and you need display devices. And they may be the same, or they may be different, separate devices. So there's Intel RealSense. They've come out with a 3D camera that I actually have one of them. You could get one of these. It's about $99. It's not very expensive, and connected to a Windows 7 and up PC. Or there are some laptops and tablets that have these 3D cameras built in. These are actually a 2D camera with infrared sensors in them to give you the 3D effect. There's also the PrimeSense cameras that have been around for a while. Apple acquired them a couple of years ago, I think. But PrimeSense had provided the sensing capabilities for the Kinect, the Microsoft Kinect gaming system. So those have been around at least since 2015, maybe before that. That's from the capture side. And then there's also a new one, Lenovo Tango. They have an SDK that was out in the last year, and in the next month or so, they should be launching their first commercial device. And then on the display side, there's quite a number of different display devices that are available or are becoming available. So Leia has an SDK and a screen that actually is able to display a holographic image without needing glasses or any head-mounted display. And Leia as a company is a startup out in California. Leia has announced that they have a contract with a company called Altice in France, and supposedly a contract with some service providers in Europe, like France Telecom, for a smartphone that's going to have their 3D display, available at the end of next year. That's what they've announced earlier this year. Then you're familiar with the Samsung Gear. The Lenovo Tango can also do displays of AR images as well as capture 3D images. And there's a number of others, the HoloLens, the Oculus Rift, the Meta 2, Magic Leap is coming eventually. So we can see that the devices are becoming available. And of course that's important because you're not going to be able to provide any of these use cases if you don't have the devices to allow you to capture the images as well as display them later. So this summer I also had an intern to play with some of these devices. And so we had a Tango device and we had the Leia device just to see how well they worked. And I just want to show you, before we go on to the use cases, what they look like. It's not as, this is using an iPhone camera to capture this, so I'm not sure whether you get the full feel of this, but just so you get some idea. So this is the Leia display. So this is the 3D holographic display without requiring a head-mounted display. You just use your eyes. So if you look very carefully, and I tried to scan around the display, you can kind of see the 3D effect. Okay. And then I have one more, which is the Tangle video. Oops. Sorry. So with the Tangle video, what we did was we actually used the Intel RealSense camera, and our intern moved around her head to do a capture of a 3D selfie, and then used Unity to render it to display onto the Tangle as an AR image. So let's do this again. Sorry. So if you look here, we were walking down the hall in our building. You'll see there's an actual person back there, and this was the image, the selfie image that was put on top. So it's sort of like a Pokemon Go with your own selfie on it. Sort of like that, right? Okay. Okay, so I wanted to show that there's actually devices that will allow you to actually make some of these use cases real. Okay, so let's start off with, so there's three main categories of use cases that I want to talk about from an architecture perspective, and how we might be able to integrate the ARVR technologies into a telecom service provider's current IP communication system. So messaging is the simplest, right? If you can send a 3D message like you would send an emoticon or emoji, that might be cool. And the simplest version of this would be to have a library of pre-built 3D images. And there are already libraries of pre-built 3D images already available on the internet for 3D printing purposes and other purposes. So these libraries already exist. They're in different 3D image or 3D model formats like OBJ, DAE. You just need to be able to get a renderer that's able to handle that particular format to create the actual 3D image to display on your device. So one possibility is to, initially, is to offer these pre-built 3D images either from a third party or from a telco, like their emoticons or emojis, that people can use within their messaging service. And so this could be, if we're talking about telcos that are deploying IMS in RCS, it could be something that you could integrate into an RCS message, for instance. At some point, when devices actually do have 3D capture cameras in the smartphones themselves, then we could go to user captured 3D images and have those be possible to provide in a message. The user captures a 3D selfie and then adds it to their message and sends it to their buddy. So that's a possibility too. What I'm showing here as an architecture is for the pre-built version where there's databases already available. We've got edge clouds also here for the purposes of being able to save on sending bandwidth, using high bandwidth all the way from end to end. Rather than doing that, some possible architectural enhancements could be that you, instead of the originating end device actually downloading a whole 3D image into the device and then carrying that 3D image all the way from the originating party device to the terminating party device, then maybe you could put in a pointer to the image, and then it could be that a network element, maybe one of the CSCFs or an app server, could be the one to actually add the OBJ file or the 3D model file into the message while it's in the network. So you're not sending it over the air, until you have to. Okay, sorry. Oh, 5 more minutes? Sorry. Okay, so quickly. Another possibility is conferencing and collaboration. Conferencing and collaboration is the... now, again, you could have pre-built 3D images, or in the future, you could have one of the participants create the image on the fly, and then all the participants in the conference are able to see the image. Plus, eventually what you want to be able to do is provide the capability for interactivity so that any user is able to move the image and the other people in the conference are able to see the movement of the image and possibly editing of the image. And there's some architectural enhancements or standardization that would probably be needed in order to be able to do this. And then the last use case would be supporting holoportation. And we're actually doing some experimentations, and a lot of companies are doing experimentation on being able to take multiple camera angles using 3D cameras to capture a live 3D scene, and then take that captured those captured images from the multiple camera angles, stitch them together, create an implicit geometric representation, then create the final mesh and texture 3D model, OBJ file, that is input to a rendering engine to then create, to then recreate the image on the terminating party side. So we're working on that. And one of the things I want to point out here is that we probably would want to put some of this processing that would be necessary in edge clouds rather than in a core cloud, so that you can eliminate the need to utilize more bandwidth than you have to in the network. And you also want to offload some of the processing from the end devices onto the cloud as well. So the creation of the modeling, the 3D models of the images, requires heavy processing. The rendering requires some medium processing, and then the bandwidth in between some of these different processing steps have different amounts of bandwidth that's required. So as you can see here, I tried to point out that between creating the implicit geometry representation and generating the mesh and texture requires medium bandwidth, and then between the mesh generation and the rendering is high bandwidth. So you really want to put that at the edge clouds as much as possible. Of course, could be standardization that is required, but for the purposes of prototyping, you won't need to do that. Okay, and in summary, the ARVR market revenues are going to reach $120 billion by year 2020. There are telecom opportunities for the ARVR market. It includes leveraging an edge cloud for dealing with high bandwidth needs and low latency requirements. IP communications that the telecom operators are already deploying could be leveraged and enhanced with AR/VR technologies to offer AR/VR communications solutions. And there's markets in many different areas, in consumer messaging and enterprise conferencing and retail sales, many different possible verticals as well. And there's a number of areas that may be impacted as various standards bodies and partnerships that would have to be created in order to get an end-to-end solution out there. But there are possibilities, and what I wanted to do was offer what some of those potential solutions could be. And I think I've run out of time.
Yeah.
So
Thank you very much, Anne. Okay, it's definitely one of the first times I've heard a new application for IMS which I hadn't seen elsewhere in communications industry, so quite like that. I know that Ronnie has to catch a flight, so if there's any questions, Annie, you're around for a few minutes, or have you got to shoot off now as well?
I actually